Alrighty, let me pull the single slides and for a quick introduction. So, hi everyone. Welcome to all AllERCDevs of Season 2, Episode 5. We have Jake, go by JXOM, to present his perspective about 5792. We also will be expecting Frangio to give us a briefing of a newly proposed EIP 7713 for box type of 712. And then I'll be sharing 5269 ERC discovery interface, which intended to be an upgrade of 165. And in the particular context of 172, context of 1271 plus 712, that was a context cases brought by and inspired by Vectorize. So this is it. So first of all, let me welcome Jake. This is the first time he called in. I'm glad this time worked for his time zone, which I think is calling from the east part of the Earth. I don't know how much you want to share, but thank you for being here.
No worries.
Yeah, so the next 15 minutes is yours. You can use however you want. Many people would like to ask questions, so we suggest you leave some time for people to ask questions. And by no means this is trying to be the seminar that solves one problem just with this. It's more about directing the right amount of attention from a good audience to particular problem they're raising. Either you're asking people for review or either you're asking people to adopt something. So yeah.
Cool. Yeah, well, I just prepared a bunch of slides before this talk just because I like presenting slides and stuff. I think it's easy to like convey information. Yeah, so I'm basically going to talk about ERC 5792, which is the wallet call API. I'll just give a brief introduction to myself. I'm Jake. You can find me on Twitter _underscore JXOM. I'm from Melbourne, Australia. It's 9 a.m. outside and it's pretty sunny. So I might go outside today because I haven't been outside for a few days. Yeah, I do open source at Wevm. So we work on TypeScript tooling and libraries for Ethereum. Our most notable libraries are VM, WAGMI, ABI type, and a couple of others. And yeah, previously at Rainbow Wallet, and I've been a co-author of 5792. Yeah, so what is 5792? It's pretty much the wallet call API. It's a new JSON API, it's a new set of methods for facilitating the sending of calls between a dApp and a wallet. This is not to be confused with reading calls or multi-call. This is like for sending calls. And ERC 5792 comes with like the included capabilities of batch calling, atomic batching, if like a wallet supports sending multiple calls as part of a single transaction, sponsored calls where the wallet may want to cover gas fees, and then permissions and session keys, which enables wallets to perform calls on behalf of the user without their explicit approval. And yeah, this is the ERC here. I'm sure you know how to navigate to this page. But essentially, Moody initiated this ERC a couple of years ago, and then a couple of months ago, it got revived by Lucas and Wilson at Coinbase. And most of the credit of this ERC goes to them. I was mainly a reviewer and someone who gave feedback to this ERC. So that was mainly my role there as a wallet and dApp library author. Yeah, so why ERC 5792? So I'd say that ETH send transaction is pretty limited in its feature set today. It was mainly built for EOAs. There's no efficient way to send multiple transactions. In its current state, people would attempt to send multiple consecutive transactions to a wallet, but this is quite a harmful user experience because you don't want to have like users clicking accept transaction approvals like 10 times in a row or something. And it's also has its browser constraints too. Like, for example, in iOS browsers, it's hard to initiate multiple pop-ups and stuff, or deep links, I should say. And there's also minimal support for smart contract accounts. It depends if like the wallet handles smart contracts as part of their send transaction handler. And it obviously doesn't support paymasters or permissions, session keys, etc. So due to the limitations of send transaction and the advantages that send calls offers, long term, I would predict that send calls supersedes send transaction, as it pretty much covers all the existing cases. And also, not to be confused, the term call is similar to a transaction, but it's not the same. For EOAs, a set of calls generally represents a set of transactions, whereas for smart contract accounts, a set of calls may be emitted from a single transaction if the wallet supports atomic batching, or each transaction could represent a call if atomic batching is disabled or not supported. So this ERC introduces 4 new RPCs. So wallet send call. I won't say wallet. So send calls, which is basically requesting a wallet to send calls. Get call status, which gets the status and receipt of those calls. Show call status, which instructs a wallet to display the calls in their UI. And get capabilities, which enables a dApp to discover wallet capabilities. So in code, this the most vanilla JavaScript example would look like this for wallet send calls. So essentially, you first would establish a connection with a dApp. This could be done with a request accounts where the wallet would give back an address of the account. And then the dApp could send a batch of calls with that address. So in this example, we're just sending 2 calls under the mainnet chain ID with this account that we got back from the wallet. So that's pretty much send calls. It's pretty straightforward. The good thing about send calls is that it's account agnostic. So the wallet can send calls via a smart contract account or an externally owned account or an externally owned account with an invoker. No, I'm just joking. I won't go down that path. The account that's provided to the dApp from request accounts can either be a smart contract account or an externally owned account or something completely different. You never know. So the crucial thing is that the dApp doesn't need to know the wallet's account type. And this generally leads to the idealistic state of smarter wallets and dumber applications. Application developers don't need to make assumptions about the type of account to facilitate sending calls. Just let the wallet handle it so you can actually focus on developing your application instead of worrying about account complexities and going down all those complex routes and stuff. So from a high level, this is like an end-to-end high-level diagram of how wallet send calls works. So don't get too distracted about what's happening. Can you see my cursor on this screen?
I can.
Yep.
It's a little bit small, but it should be fine. Yeah.
About this. I'll get rid of that. So don't worry about what's happening in these blocks right now. So just worry about the dApp to the wallet. So the dApp instructs the wallet to send calls here. And this alt block is like an if-else block. So if the wallet has a smart contract account, then it would do like a bunch of user ops. If the wallet is an externally owned account, then it'll send a bunch of transactions. And at the end of that process, the wallet will return an identifier for that call batch, and they'll give that back to the DApp. So it's important to note that this identifier is like a wallet flavored ID. It's not a transaction hash. It's just an ID that represents the bundle of calls, I guess. But yeah, let's double click on the inside of these blocks. So if the wallet is, if the wallet is using a smart contract account, then it would sign a user operation, send it off to the bundler, and then the bundler will handle the operations, which will internally invoke the execute batch on the smart contract account, and then give back the user operation hash and all that stuff. Whereas for externally owned accounts, the wallet may send each transaction off via send raw transaction, and obviously sign each one of them, and then store the hashes in some store. So by the way, this store.set is just like a local store for the wallet. So essentially we want to store these hashes against an identifier so that we can use that identifier later on to get the status for those calls. And this leads into the next slide. So I get back this identifier from send calls, and then I can use this identifier to get the status and the receipts of the call batch. And yeah, so these receipts are transaction receipts. And this is internally how wallet get call status works end to end. So for smart contract accounts, it would get the identifier, the user op hash from the store, and then get the user op receipt, and then we'll give back the transaction receipt from that user op operation receipt back to the DApp. Whereas with the externally owned account case, it may get the transaction hashes from the store and then get each receipt and then give back the receipts. Show call status we can use to, I guess, instruct the wallet to display the calls in its UI. So it's like a deep link to the wallet. And of course, browsers will need it to be invoked via a user interaction. So dApps can't programmatically spam like 10 pop-ups or something like that. And yeah, so 5792 comes with this concept of capabilities. It's an open-ended, flexible API to define capabilities of a wallet. And dApps can discover wallet capabilities via wallet_get capabilities. And then they can use like these capabilities with send calls via a capabilities property, which I'll demonstrate in the next slide. Existing capabilities also include atomic batch. So the wallet may give back to the DApp if it supports atomic batching, or if it supports like a paymaster service where the wallet sponsors calls via a paymaster web service. And then there's also upcoming capabilities like permissions and session keys, where the wallet supports granting permissions via 7715, which is a new ERC that was drafted a couple of days ago. And yeah, so ETH get capabilities from a JavaScript standpoint looks like this. So once again, we're requesting an account or address from the wallet. Then with that address, we're going to discover the capabilities that the wallet supports for that address. So in this case, for mainnet under chain ID 1, we support the paymaster service or paymasters, and we support permissions. And with that, when we go to send our calls, we could specify the paymaster service capability, where if the DApp supplies a paymaster URL, it can cover like gas fees with that paymaster, I guess. And here's an example with like the permissions capability. So this is ARC 7715. I won't talk too much about that, but essentially it offers a new RPC method called issue permissions, where you can give it a set of permissions that you want, like the wallet wants to grant to a user. So in this case, we're we want to issue a native token limit permission, which means we want the ability to spend up to 1 Ether on the user's behalf with an expiry date. And yeah, this wallet issue permissions will show like a pop-up or a request to the user to accept this permission. And with that, we get back like a context, which is like an identifier for that permission. And then we can use that identifier in the capabilities section of send calls. And what this means is that if a user grants the permission to spend up to 1 ETH, that means we don't need approval from the user when we go to send calls. The wallet can just perform the execution on the user's behalf. Obviously, there's security concerns around this, and that's in the rationale security section of 7715. But essentially, this enables session keys or permitted calls. And there are also other types of permissions in this ARC, like whitelisting contract call signatures, rate limiting for like recurring calls, the native and ARC20 limits, as well as gas limits. Future considerations for this ARC may be specifying chain ID per call for more intuitive multi-chain behavior as we start to focus more on chain abstraction, and also more capability ARCs. We have ARC 7677, which is the paymaster ARC, and 7715, which is the permissions ARC. So I would expect a couple more of them. Wallets that support 5792 are currently Coinbase Smart Wallet, which is obviously smart contract accounts, Safe Wallet, which is also smart contract accounts, and Rivet, which is like a dev. It's not a real wallet, I should say. It's like a dev tool for Anvil, and that uses externally owned accounts. But Rivet also supports 5792. Tooling that supports 5792 is VM, which is just a TypeScript interface for Ethereum. WAGMI, which is React and Vue composables for Ethereum, as well as a vanilla JavaScript or TypeScript interface. And also Third Web, which provides hooks and vanilla TypeScript interfaces for 5792. And as an example, here's the VM docs, which I'll go to the send calls section, which is more interesting. So this is the VM docs for send calls. So with your wallet client, you can request to send calls. It's pretty similar to the API I showed before, but it comes with cool type inference on everything. So a user won't be able to make mistakes, hopefully. You can learn more at EIP5792.xyz2, which was made by Lucas at Coinbase. Pretty good docs for 5792. So that's about it from me. Yeah, thanks for listening. Stop sharing.
Thank you. Thanks, Jake. Thank you for pointing people to this important proposal. Any questions that people want to ask, or any comments, feedback, call for adoptions?
It looks like Lucas is here too, so that's good. He's like the main author of this ARC.
Yeah, we have William, we have Franjo. William, do you want to go first?
Hey, hey, Jake. Thanks for sharing. I think these are two interesting concepts. So it's got the abstraction. So this is obviously something that's really important. We don't have abstraction. We've got best practices that you should not be using externally owned accounts. We've got a lot of smart contracts and business people that want you, they're assuming you have externally owned accounts. The MetaMask, all of the RPCs, they're expecting you to use externally owned accounts. That's in there. Also, we've got batch. Honestly, I feel like the justification for batch transactions is weaker or not as loud from the dApp community. You know, we want to do 10 transactions. I feel like that's less. Even if you want to do 10 transactions, maybe you should just do an approve for all transactions and then 10 messages. So even like send 10 messages seems more important to me than send 10 transactions. So just practically, I'm wondering if this proposal may benefit from two separate concerns. It is two concerns right now. One is the batching and one is the smart contract accounts. And I feel like if I had to pick one of the two, I would focus on the smart contract accounts first. And that could even be done with the existing RPC, which is just send transaction, but the transaction would either go through EOA or the transaction would go through a wallet in some new defined behavior. And I think that would upgrade, that would be a clear upgrade path for all the existing dApps. If you can do an existing RPC call to do an EOA transaction or an existing dApp with a new wallet transaction, I think it's going to work cleanly for a lot of things. But it allows you to sneak in the new RPC because you always want to get a new EIP going. You want to sneak in a new RPC. You know, that's fun. You do get a new capabilities one. So you could just do existing send transaction with smart contract accounts. So fun, works with everything already, free upgrade, no controversy. Plus you add your capabilities, and that is your future looking thing. So that was just my thought practically of how to do this, because I don't think it's going to be easy to get all the dApps to switch to a new thing, A, and B, not everybody needs batch. So if we don't need batch, I don't think we need a new RPC method for right now.
Yeah, I agree that there's like two things in this ERC, which is the batch and the capabilities. I feel like we benefit a lot more from all the capabilities stuff than batching right now, but I still think batching is still important. But yeah, it's good feedback.
I want to also mention that what Franjo is about to share in the briefing is one of example of new capacity that could be introduced. But yeah, I saw that Francisco raised his hand. So Francisco, you want to go for it?
Yeah, I love this, by the way. And I think the main point is the batching, like because each send transaction can already support smart contract wallets, and I assume I think it does already. Well, I don't know about that.
Yeah.
So I think the main thing is the batching and the extensibility with different capabilities. So my question is, can you clarify what layer has to implement this? Like, is it the wallet apps, and like, how is Wallet Connect, for example? Does it play any role here with regards to the RPC call?
Yeah, so mainly the wallets handle these RPCs. So like, for example, like Wallet Connect would establish like the connection between the wallet and the dApp via like an 1193 provider. And a dApp can use that provider to send off the wallet RPCs. It's like similar to like a browser where you may want to use 6963 or window.ethereum to send off that request as well. But yeah, it's the source of where this business logic is happening internally is in the wallet, and the wallet handles the RPC requests from the dApp. So the dApp doesn't really need to have background on or make any previous assumptions about the type of account, I guess. What's Lucas saying here?
And my other question is, would it make sense to have a wallet sign, like for signatures, and like to move everything that's account related to this kind of new namespace, including signatures, instead of just sending transactions. Do you know if this has been discussed?
So you're talking about wallet sign transaction?
Well, this would be like a new wallet endpoint. I mean, because now it's only like for sending calls, right?
Yeah,
and
this
it
is like
doesn't
kind of
cover signing messages.
Yeah, this is completely independent from signing, I guess. So, yeah, that could be something else if it wants to be.
It could be okay. Yeah. Well, I'll look into the discussion. Do you know if it's close? Do you feel it's close to getting finalized?
What do you think, Lucas? I think it is pretty close.
Yeah, I think so. There's a chat I was actually planning on this week, proposing that we move it to last call. So
cool.
Exciting. I actually want to follow up, touching the point that Francisco touched about signatures, especially if one of the main use case would be the batching. To what extent does the app wallet and the connection between them should assume confidentiality? Like, because what Francisco is proposing later is about replay attack, to prevent replay attack of signatures that's being used in 1271, etc. Right? So if someone can send a request in the wallet and maybe send batch transactions into the wallet, do they carry signatures? Or it seems like in your charts, sometimes the wallet come back to ask user to sign, right? To what extent should wallet and smart contract designers figure out how to make sure that replay attack, or maybe nonce, maybe expiration being in place, so that there's proper assumption in the security or attack model that we're preventing here? I wonder if the discussion related to that has been talked about a lot in the 5792 discussion.
I think that concern is a bit independent to this ARC, because we're not asking the DApp to sign anything. The DApp is just providing us with like literally just at a minimal like two value data properties. Like there's no signatures being transferred. But the wallet does internally, like when we go to handle these handle these calls internally in the wallet, then the wallet would facilitate the signing and stuff. But this is like independent of the connection between the DApp and the wallet, I guess. So the wallet would do that after internally.
I guess the complication is that it's beyond wallet and DApp, right? Because once the DApp sends a request for the wallet to sign, let's say one or multiple transactions altogether, some of them could be signed in a smart contract and go to and the transaction be shared to a paymaster for them to execute. So it's rather not. It's very different. The signing model and the attack service of a signing model is very different from assuming it's only EOA, right? That its whole ecosystem exposed to those signature that has not been checked in and confirmed into the blocks, right? So maybe I guess that's something to be considered in a security consideration. If something's already signed, even if they can go in or not go in, at the moment, somebody who have access to that information could take them and then do a replay attack outside of this whole ecosystem.
Right. I don't think replay attacks are really possible with 5792, as the signature and the signing and the sending occurs at the same time, right?
When they carry the signature, that can be used in a different way. For example, if they carry signatures of 1271, which I think Francisco would share later in a news interface. So they're not just the signature for the transaction themselves. A lot of times those transactions have approval signatures with them. For example, if someone says, "Okay, I'm gonna sign a safe multi-sign, and these are 5 signatures that I'm going to submit through this," right? And even if they didn't go through, somebody who get exposed to these 5 signatures can just take them to execute them outside of this setup, maybe a different setup. So that's like one of the example of potential security attack surface.
Yeah, right.
Yeah, Lucas, you want to comment or?
Yeah, it's an interesting call out. To me, that feels more like consideration for like the account implementation. I think I agree with Jake that I don't. I think I'm kind of struggling to see specifically how this is different than the security model with like the current. If you send like an ETH send transaction, right, and there's a signature in there, like the security model isn't different for wallet send calls, right? So maybe the call out would be like, hey, whatever assumptions you're making for like ETH send transaction, whatever security considerations you have there, you should apply to wallet send calls. But I agree with Jake in that, like, I don't think that there's any new kind of security considerations specifically as a result of 5792.
Makes sense. Thanks, Lucas. Anything else before Jake? Before we move on to next action agenda item.
I think I'm all good. I'll move on to the next one. Thanks.
Okay, cool. Yeah. Next would be Francisco briefing us about 7713, a new proposal he's working on. I guess it's a good time for him to point people to early attention to it.
Yes. So this is not specifically about replay, but it's in motivated by it. Can you see my screen? You can see my screen, right?
Yes, I can see your screen.
Good. So this is an addition to 712 signatures that I am calling the box type. And it's called like this because it's similar to boxed values in a specific way. And we can look at one example first. So this is an ERC, recent ERC, which is called 7683 cross-chain intents, being kind of pushed forward by Uniswap and one of the bridging protocols. I don't remember right now. Sorry, but I saw this really interesting pattern here that I've seen elsewhere, where they define a struct, right, which presumably would be signed as a 712 signature, and they want to make this extensible. So they add like a order data struct member at the very end, which is a byte, and this is like can be anything, right? You can take any kind of value or struct or anything and just encode it and put it in here as a byte thing. And this is because it's implementation specific and it's like irrelevant to this standard, but they wanna leave it flexible and extensible. And this pattern works, and we use it a lot also in like function calls when you have a type that you don't know what it'll be. But in the context of 712, it has an interesting consequence, which is that when the user is presented a signing dialog, this is going to show up as a hex string. So like a bunch of hexadecimal characters that are not interpreted in any way. One of the points that I'm making in the motivation section of 7713 is that the value of EIP 712 is how it's very general purpose, and wallets are able to implement this very general purpose interface where each one of these parameters will show up very clearly and say like, well, this is a cross-chain order, the value of settlement contract is this address, and so on and so on. And the user can review this in detail before deciding if they want to sign it. But when they get to the order data, here they're just going to see something that doesn't mean anything to them. And they are either very technically savvy and they'll go somewhere else and decode it, or they'll trust the dApp that's showing them this data to decode it for them, or most likely they'll end up ignoring it, which is a very bad outcome. So 712, I think it's amazing because of this general purpose nature, and the general purpose user interface that it allows for. So I think clearly there is something here that is not accounted for, and we need a new thing for this, so that we can say, well, I want a standard cross-chain order struct with an extensible arbitrary order data here, but I don't want to do type erasure and like just put it as a bytes, because I wanted to display clearly to the end user. Another similar, this showed up, a very similar thing showed up in the context of adding replay protection to 1271. And the way that Vectorize here worked on, developed to protect against this in the Solidity account implementation is essentially by putting the in here context is kind of arbitrary typed data, because the original struct can be anything, and you put it as a member of the type data sign struct. But the result of this is that now kind of reproducing the encoding of this entire thing according to 721 depends on the type of original struct. So the signature grows in size, and it grows to arbitrary size because you need to include the context type here. And this is super clever and it works really well. But you also had to compromise on like flattening here everything, which otherwise we would have wanted to put in like a nested field in the struct, and then it will get really complicated, or in fact impossible, if there were like two of these. So this is because 712 is not expressive enough, and it needs a new feature in order to solve this. So what I'm proposing in 7713 is, again, the box type, and this is it's a new type called box with special encoding behavior. And in particular, what it does is like the contents will have a struct type, but the type of this will not show up in the encoding of the outer type. So it'll just show up as box, and whatever is inside it, which may be like it could be like a cross-chain order, it could be like a implementation-specific cross-chain order. It's not going to show up in the encoding for envelope, and this allows us to standardize the outer type in this really arbitrary general purpose way. And it actually allows us to recover, again, the general purpose interface that the wallet can build. So the specification here, the details don't matter. The important thing is like this is a box, contains something inside of it, but envelope can be agnostic to whatever is inside the box. If you want to know what's inside the box, you can confirm it. You can be given, oh, this is the type of what's inside the box, and you can confirm it. But otherwise, you don't really need to do that. In the context of 1271, what this will imply is basically that this part becomes constant size. It'll just be a byte 32. And that'll be enough to reproduce all of this. You will still have this, but contents here would be a box. You would be able to put all of this inside a nested member, domain member if you want. And you would be able to have two of these if you want it. Although in this case, it's not what you will want. And I think this would improve the expressive power of 712 signatures quite a bit. Now, I'm really concerned about whether it's even feasible to extend 712, but I think we should be optimistic. It might take a while. We might need a sign type data v5, but if this is something that's useful, and we already have two, I think, very valid use cases here, it's something that we should try to push. So I'm going to try to do that and see where it goes. Happy to take questions now, if any.
Yeah, William, do you want to go ahead?
Hey, thanks for sharing. This is at the forefront of what we need. I'm not sold yet. I mean, I'm still studying what you presented. Thanks for sharing. I'm still studying how we should do this. Sign type data v5 at a minimum, we need that. Unfortunately, sign type data v4 is still not even properly implemented everywhere, anywhere. And
Can you provide detail on that? What's
yeah,
missing?
like when you're signing orders on maybe not like in
Oracle,
MetaMask. So MetaMask, I mean, even normal transactions, even set approval for all, you're reading bytes. I mean,
Yeah.
the pop-up has bytes in it, so it's like
Best case, maybe they show a JSON thing, which is not great either. I've seen some that do this better, but most just show a JSON thing, and it's
Yeah.
infuriating.
Personally, I think the most important thing is like logging into website. We need to standardize that. I don't even know how to standardize that, but the pop-ups we're getting suck. The pop-ups suck. The pop-ups are not helping people. We're still reading bytes all the time, and we're still doing things, and we have to like scroll down. And even if you don't scroll down, you can click accept, and it's like you don't even know what you're signing. And this, but I do believe that signatures are the most important part of blockchain. Signatures are more important than transactions. Signatures are more important than blockchain, and signatures are like level 0 networks where your identity can sign things. So I think this is the most important thing we should be working on, even more than any other blockchain thing, is exactly what you're presenting here. So, but V5 might be the way to do it. The types might be. You're doing type erasure. I think, so would you call this a type erasure?
I wouldn't call it. What I think, my point is that order data, the bytes order data example that I showed, that is type erasure. That's just equivalent to using a void pointer in C. This is more like a dynamic type, where the type is sort of a part of the value. But I tried really hard to find analogies in programming languages. I think dynamic types are the closest thing.
Cool. I need to read this more and catch up more, but this is where I'm at so far. Thanks.
Yeah, I just want to point out this. This is like the super early draft. Francisco just drafted, and then I encourage him to kind of point people's attention to it. Please follow up and pay your attention to the development of this. And thanks, Francisco. I have a quick combination of comments here. Is that when I saw wallet _ send calls, this is like a typical thing, and then yeah, I'm glad that it can expand to like multiple transactions, and then it can deal with then a smart contract, so as well as EOAs. I think what 7713 constantly remind me is the need for user and wallets to know what they're signing for. So and then maybe made it readable and visible to user. I wonder if that consideration is included in 5792 for, let's say, if a friendly, amicable DApp trying to tell the wallet, hey, in addition to what I asked you to sign, here's actually how we come up with that call. Here's how we come up with the hash. Here's the content if you want to provide to the wallet user with more context. And you can also hash them back and see if it actually matches what the user was, what I asked you to sign. Is that kind of consideration included in the, or did it ever come up as a discussion in 5792?
Well, I guess. Oh, here you go, Lucas.
Sorry, I was going to ask you to repeat because I think I missed it. But Jake, if you have an answer, go ahead.
So yeah, let me repeat my question. In what Francisco showed, the motivation of 70713 is that instead of letting users sign a random unreadable string, he is trying to make it more structure and allow more structured data to be presented in a hash, in a pre-hash structure. Now, does 5792 has a discussion about how to expose those structured data to users so users know better what they are signing?
Short answer is no. Maybe Jake has more color, but we talked about adding like signing methods to 5792, but we decided against it ultimately. I guess we kind of tend towards and kind of like the opposite of what William's thinking, like giving more control around like the transactions. So we're actually trying to provide an alternative to like for the batching case, for example, you know, the like signing argument is like, you know, use permit to, you don't need to batch approvals and sends. But we kind of are like arguing for the other side of that argument. So we decided against including like other signing methods in 5792. Jake, I don't know if you have anything else to add.
Yeah, I was just gonna say that. Yeah.
I have some thoughts about this. I think Victor's getting something interesting, which is that in 5792, when you send calls, right? We're not talking about signatures, just about calls. The data field in each call is a byte string. And wallets have to jump through hoops to decode that, which the dApp encoded it, and now the wallet has to decode it to show it to the user in the form of like, well, here's an address, the second parameter is an integer, and so on, right? And that's actually, in my opinion, an unsolved problem, because although wallets are doing this, they are either only doing it for a few cases like ERC20 transfers, or they're relying on the centralized Etherscan's ABI verification. And I mean, this new endpoint, RPC endpoint, sounds like an interesting opportunity to, instead of sending an opaque byte string, to send, okay, what I'm doing is calling this ABI method with these parameters that you can show the user in this detailed way, and then the wallet will do the encoding itself.
Yeah, I think that's actually a really interesting point. Immediately, like, I feel like there's a lot of security considerations there, but I think it's worth thinking about. I think it's really interesting because you're right? Like, if you want to show like a user what some data is doing, like in our case, you have to go and simulate, and you have to rely on having this big amount of data and like knowing what contracts you're interacting with, and it's not an easy problem. But yeah, that's an interesting thing to think about.
Yeah, for the record, I don't think this removes the need to simulate, but it is like a small first step to at least show the decoded contents of the function call.
Yeah, because I guess like wallets currently rely on like mainly centralized signature databases to extract those signatures. So like, yeah, it is something to consider in the ERC as well. Like if the dApp may send like a function signature along with the data, so the wallet doesn't need to rely on extracting that signature from the first four bytes of the data from a centralized location of some sort. So yeah, that could be pretty good to consider.
Yeah, even one step further for things like permit to, right? If any send calls include hash and a signature for a permit to, that information is completely lost, right? They're not extractable, they're not decodable at all, and then we just become an increasing threat to users' fund because of the phishing and then all the malicious sites. So this probably could be one. And by no means, I think we should move forward in 5792. I didn't meant to suggest to slow down finalizing or not, but maybe use it as an opportunity to think about, let's say, if we put in an extension field for that JSON definition, in case in the future, to include those schemas, those data to be appended to it, and there's opportunity that we can expand. I have no doubt that 5792 is going to be extremely important, and it's gaining enough support. We should like move fast. Yeah, that's like more of an editorial consideration. Like if it cannot be done within the scope of this particular one, yeah, we should like find a way to have some room to include them in the future. Yeah, thanks, Lucas. Alrighty, we have 5 minutes. Supposedly there's another topic, but I don't know if we have full time. But let me briefly use what we discussed as a motivation to share with you what I have proposed a few some time ago. It's 5269. Let me check. 69 discovery, and then I think Vectorize here. I guess he used an example for so when ERC 165 came out, it has a lot of support, and then it's great. It has done a lot of great things. But there's also limitation. One of the motivating case for introducing 5269 is it's hard to define behaviors that doesn't have a method exposed, right? So if you know how ERC 165 generates their signature, it uses support. You use support interface, and then basically you have to like get the function signature and then maybe pack them together for multiple ones to generate an ERC definition. The benefit, of course, is that as long as you have the same function method, it's always the same for the interface ID. It's unique and it's reliable. But it also have a lot of limitations, and so 5269 is trying to declare some kind of support ERC, and then we believe that actually tracking what function ID is not very useful, because if a contract doesn't want to do what they say they do, they can always do that. They can always like treat you to believe that they are compliant, like if they want to play that game. So it doesn't mean it's not meaningful. It's more about a function declaring who they are, and it's up for the client or the calling contract to determine, okay, whether I trust them or not. So doing a support ERC and then define a bunch of identifier and then return, you can use that to identify whether there's a new behavior introduced here. For example, if you want to accept some kind of box into your ERC 1271 signature for some structure, you can define them in this way without creating arbitrary functions. And also it's much better against the mining attack, or if people trying to mine the same function interface. So this is one of the reasons that I propose it. There's other reasons. I Vectorize here. If you want to comment a little bit, I think you make a better argument than me.
Okay. So the thing is, I was considering like how to automatically detect like, let's say if I implement 1271 in a different way than others, how do I allow automatic detection? And the thing is that 1271 only has one function, is valid signature. So it's not like it does not lend well to 165 unless I somehow define a dummy function just to make the interface different. So one option is using this 5269. I was also thinking like, what if we just define some kind of naming scheme to make the dummy function? I think maybe this 5269 might be more generalized. Oh,
I think you're cutting off. You're cut off for a minute.
oh, okay. Sorry. My signal is bad. Okay, can you hear me?
Yeah, I can hear you now.
Okay, so the idea is suppose I'm implementing something special for 1271. There's only one function which is valid signature. So although the behavior of the function is different, I have no way to create a new identifier for 165 unless I create some kind of dummy function. So this ERC gives me like the flexibility to display, to signal to front ends that my 1271 is slightly different. So I'm considering using this for the ERC I'm proposing.
Thank you. That's an indirect call for adoption of. Thank you very much, Vectorized. And as you see, we're trying to solve several problems here. I know that we're at time, and I want to like direct people's attention to this, and then probably give feedback. And I'll probably come back and present it in a full setup. But yeah, thanks very much. And any comments before we? I think we're at time. Any comments before we close this conversation today? And you can comment on anything that has been discussed earlier today. Going once, going twice.
Okay.
All right, just real fast on the 5269. You're competing with 160, 169, right? So or 165. So you've got an enemy already. But it was very hard to get that implemented in Solidity. And I inherited 165, so I don't think it was the best way to do it. But if I had to do 165 again, it would just be one hash, and we would use URNs. We would use a URN and then a hash of that, and that's it.
You want to have a full hash?
One URN, anything you want in the URN, a full hash of it, and that's it. And the URN could be anything anybody ever wanted. People could version it however they wanted. And anything more than that seems unnecessary. Okay. Also, I don't think that the caller is necessary. I don't think that it's necessary to ask the caller of, this is an interface. So the interface should be caller agnostic. And if there's caller specific behavior, then that should be part of the specification, which is then implicitly named in the URN and then hashed anyway. But if we had to do it again, I would do that. But there's such a strong precedent, and we're already built into the language. I mean, Solidity has this 165 support built in, and I don't see a need for another one.
Yeah, I'll take that in a next full presentation. I'll defend that. Vectorized, do you also have comments?
Oh yeah. Regarding the box EIP, I think I'm trying to imagine how it will look like when we define, the encoded type.
Encoded.
Yes. Somehow you need to hash the encoded type whenever you compute a EIP 712. And I'm not sure how it's done.
Cool.
But never mind. I just wait for Francisco to come up with more examples.
Yep. I guess, Francisco, you kind of have to come back and present again.
So I invite you to read the EIP. I mean, I think the short answer is that the encode type for boxes is new. Like it's kind of overwritten. Yeah, you ignore the inner type. But if it's not clear in the EIP, I'm happy to review it, and we can talk about it offline too.
Okay, sure.
Well, all right. Thank you very much for attending AllERC Dev of the Season 2, Episode 5. We really appreciate the presenter, Jake, Francisco, me, and Vectorize. Thank you for coming. Lucas has shared his interest in presenting multiple ones. I really look forward to it. Pram here is going to maybe share with us ENS IP when it's proper, when we find that draft mature in the future. If you want to follow up on future discussion like this, please don't forget to join the Discord, join Telegram in the screen. We look forward to meet with you and collaborate on ERC. Thank you all builders and authors for being here today. Yep. Alrighty, I'm gonna close it out.
I will remove